Let's go through LeetCode 576 outer boundary test. For this question, to give us a M multiplied by a matrix and a maximum move, which means how many steps you can move, and also a start position, which is start row and start columns, and ask how many number of the paths we can this ball can move out of the boundary. For this kind of matrix issue problem, right? So intuitively, what we put is that we should put those kind of in direction array, right? And also the column. Also, the number, it can be very big, right? So we should have a mod. What we're thinking about is that we for every ball, right? It has 4 directions. And for these 4 directions, and we for example this kind of matrix, right? For each 4 directions, so we should have some recursive code, right? And so we think about doing the DFS to solve this issue. The X condition is that the ball going out of a boundary. So if the row equals -1 or row equals M, right? Or the column equals -1 or column equals M n, then return 1, right? But for this question, they may have some kind of duplicate calculations. For example, if this row, right, that goes here, for example, it has how many steps? Have 2 steps, right? Maximum is 2. And so let's assume this maximum is 4. Okay, so of course he can go here, right? But if he goes here, then he has 3 moves left, and goes here, has 2 moves left, right? And for a ball has 2 moves left at this position, we add to our result, right? And but if he goes to this path, right, it has 3 steps left, and then goes to this path. This ball has 2 moves left, and at this position again, right? So we'll see at this position, 1 1, right, has 2 moves left. We already calculate in this path. So the thing is that we should use some kind of memorization to save it, right? To save the duplicate calculations. So the DFS plus memo can be our solutions, right? So let's have a write code, right? We can use the this kind of integer. So that means if this value is none, that means we haven't calculated before, right? What's new int m plus 1. Actually, we just need m, right? Because m and this maximum we should have it, right? Because we also want to save this value, right? Just return DFS m n and start row, start column, and our maximum, that is current move left, right? And the memo. So this DFS is return how many paths? DFS is inter row, inter just say M, okay, inter N, and inter row, inter column, and inter remain, right? How many moves we left? And also we have a memo. So that things that we should have some kind of conditions, right? So if we check if memo contains this value, right? If memo row column and remain doesn't equal to null, we just return this result, right? Return memo row column result remain. And the things that let's look at the X condition, right? If row equals -1 or column equals -1 or row equals M or column equals A, then we should return 1, right? And actually we can save this value as 1, right? We have memo row column remain equals 1. Okay. And the things that if we have remain equals to 0, we should just return 0. So we have, for example, long result equals 0. Okay. So for int k equals 0, k is smaller than 4, k plus plus, right? So we should have result plus which equals result plus DFS M, and so we should have row plus D row, okay, right? And column plus D column, okay, and had the new position, and our remain should be -1, right? And we have memo. And for this one, we should mod, right? MOD. And we should save this result to our memo, right? Memo row column remain equals, let's convert this as int result, return int result, right? Start column. If because the things that we also save the this kind of we want to save the -1 and M into our memory, right? And actually for the outer bound problem, let's do this. That's for the outer bound outside, okay? So that because that means that we only open this array as m multiplied by n, right? So for this kind of case, we just return. This is also O1 check, right? So this is the outer bound condition, right? So if we put the outer bound condition here, and then for this one, then we check if we save or not, right? Okay. Convert this to Python code should be very similar. So we have for example, we have the D-row D-column as D-row equals 1, 0, minus 1, 0, right? And the D-column equals 0, 1, 0, minus 1, right? And we should have a mod, right? Mod equals 1, 0, 0, 0, 0, 0, right? So we also need to have a memo. Memo equals for example, we can put as actually minus 1 for in range. Range max no plus 1, right? Minus 1 for range. And this one for this one in range, and right, and we should also we should have another one, right? That is for in range. And so this is our memo, and return DFS M and start row, start column, max column, max and right? So what we do is that we need to have the define the DFS, right? DFS should be M and row column remain number, right? It is return our integer. Of course, you can set this one. Let's see, get its type, right? What is this? This is int. Right, like this. Then goes to int. So we'll say if row equals -1, or row equals m, or column equals -1, or column equals m, right? we return 1. If we remain equals 0, return 0, right? And let's try to check whether this we calculated the memo or not, right? So if memo row color remain down equal to -1, right? Return memo row color remain. And that's how result equals to 0, right? So for k in range 4, we should have a result equals result plus DFS M and row plus should have a self dot d row k and a column plus self dot d column k and remain -1 and memo. And we should have this one mod, right? Self dot mod. And we'll have this one saved to our result. Memo row color remain equals result and return result, right? How to define this, right? Actually, in Python, if we don't put the type, should be fine. Data comma in define this line for -1 for this one in this kind of range. Okay. So for this one in range n, and for this one in range m, range memo equals, this is -1 for range maximum +1 for this one in range m, for this one in range n. What's the issue? Maximum +1. This one in range. None. -1 memo equals -1 for this one in range. So this part m, perhaps if I get a comma. Here is a space, right? Here is a space. Okay. So the time complexity is that if we have moved to this position, right? And also the what kind of moves left? This kind of state can be m multiplied by n and multiplied by the steps left. So that is if we already calculated this kind of state, right? We will not calculate again. That means our time complexity will be m multiplied by n multiplied by max moves. And space, right? Space is also m multiplied by n multiplied by the max moves.